What's poppin' YouTube? Welcome back to Advent of Code 2023. I'm Chris, and last night we conquered the gear ratio challenge, navigating through the twists and turns of code to ensure our gears were spinning in perfect harmony. If you missed the action, catch up and join the code adventurers as we tackle these festive coding challenges together. Tonight is day 4, and I hope you've got your coding caps on because we're diving into another exciting puzzle. I've got my ID ready, and after spinning my wheels through a few bugs in the last challenge, I'm more determined than ever to crack the code tonight. So grab your coding beverage, clear your workspace, and let's embark on this coding journey together. If you're new here, don't forget to hit the subscribe button, give it a like if you're excited, and ring that bell to stay updated with all things Advent of Code. Code Adventurers, are you ready for day 4 of Advent of Code 2023? I know I am. So let's jump into the code and see what festive challenges await us tonight in 36 seconds. Alright, in all seriousness, I've been using ChatGPT as a running dialogue each night. So as I complete each night, I update ChatGPT with what occurred the previous night, and I ask it for a new YouTube intro video of tonight's night. For the most part, I've used it verbatim. I've made a few edits here and there, but it's kind of fascinating where you get a running dialogue. But let's get right into it. All right. Day 4, scratch cards. The gondola takes you up. Strangely, though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As the circles of snow island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into the station. As you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Oh, hello. The elf excitedly runs over to you. How may I be of service? You ask about water sources? I'm not sure. I just operate the gondola lift. That does sound like something we'd have, though. This is Island. After all, I bet the gardener would know. He's on a different island, though. The small kind surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Tell you what, if you can help me with something quick, I'll let you borrow my boat, and you can go visit the gardener. I got all these scratch cards as a gift, but I can't figure out what I've won. The elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has 2 lists of numbers separated by a vertical bar. A list of winning numbers, and then a list of numbers you have. You organize the information into a table, your puzzle input. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appears in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the point value. In the above example, card 1 has 5 winning numbers and 8 numbers you have. Of these numbers, you have 4 of them are winning numbers. That means card 1 is worth 8 points. 1 for the first match, then double 3 times for each of the 3 matches after the first. Card 2 is this example, 3, 4, 5, and 6. So in this example, the elf's pile of scratch cards is worth 13 points. Take a seat in the large pile of colorful cards. How many points are they worth in total? Okay. So we'll start with this. This is our test input. Seems pretty straightforward so far. And our value is 13. It doesn't ask any specific about cards, so I'm just going to throw the card ID away. And then we can just split values. All right, so pretty straightforward is our input. What's our test value? 13. Okay, so we go back here. Our test input is 13. Run our test, should fail as designed. All right, So our command, day 4. I did forget one thing. Hold on. I was setting up earlier. I'm just going to do this now because it popped into my head. 2023. I forgot to rename the package. Okay. Sorry, I was a little behind on my setup. All right, so what are we going to do? So our input string really just looks like this. We're going to iterate through each line. And for each line, we're going to get a score, and we can take our score from this. So we already are for line in S strings dot split S that's each line, and then each line is going to have a score. I think the easiest way to do this is based on our line here. What we'll do is we'll break it into 2 parts initially. We'll just call a function score, which takes in a string, returns an int, and this will be score score equals 0. Missing a comma. All right. And then this is our input. So, all right. Easy solve. We split initially. We're going to do 2 splits. 1 just to get this part separated, then 2 to get this part separated. So the first split is going to be on colon space. Everything to the left colon space is our card value we don't really care about. And everything to the right is the numbers. I got to go back and look at the reference to figure out which one is my wins, but each set will just be turned into a slice. It's interesting. Do I have those spaces? Oh, I do have. Interesting. Okay. The lines sometimes have extra spaces. So there's more than one line. We can fix that with a regex replace all. I probably will do that for pre-processing. It'll just make this a little bit easier to understand. I don't see why we have spaces there. Let's just see if it affects our problem or not. All right, so first split. So strings dot split S, and we're going to split it on colon equal, and sub 1 is what we want. And then we want, what's our wins? Our wins are, so winning numbers and the list of numbers you have. Okay, so the wins are on the left. Right, so scratch cards. So we'll call it SC. And then so SC yeah. So the other thing we're going to split on is space pipe space, which is this right here. And so we know on the left is our wins, and on the right, so that's WP, win plays. Plays are on the right. Now we know that wins are WP 0 and plays are WP 1. So now we got to figure out what numbers we have. What we're going to do is process these into a map. Instead of doing wins and plays like this, what we're going to do is get wins. So we'll do for range of WP sub strings split WP sub 0, and we're going to split on space. Yeah, I think that's fine. So we're going to just trim the value, and then we're going to say if when equal continue. Okay, so that'll split it up and it'll give us our whole numbers. And then we don't really need to do anything with the numbers other than we do need to store them. So I'm going to store them in a map. Why a map, you say? Well, easier lookups later, so we can go through keys values. So wins sub win. Cool. All right, so that's our wins, and then we can do the same thing for plays. I would probably make this into a function, like a method. It kind of hurts that I didn't. Okay, yeah, so this also becomes plays. All right, so now that we've got our two maps, all we have to do is for the key in the range of plays, so we're going to call this our score, and we're going to say if wins our key. This is a syntax for Golang where if you just want to check to see if a key exists in a map, you can use this if okay, it'll be a bool is what it returns. With the semicolon, you can do the condition after. So you're assigning the value okay to the wins key, and then you're checking. So we can do all that in one. And we're going to say if the play is in the wins, then we know that we're matched. And we just need to do and just say if score equals 0, score equal 1. We'll continue that. So it'll break out of that for loop, or it won't break out of the for loop. It'll go to the next iteration. Otherwise, it's going to be our score equals our score times 2, which is the double it part. So I'm pretty confident just if I fix my syntax issues. Well, that would be a problem. We're just going to make it public for now. I don't really feel like giving it a different name. And then missing return score. Okay. All right, well. All right, cool. So we passed. So now all we need is our input. And then we go run day 4. 26218. That's the right answer. All right, cool. Continuing on to part 2. Part 2. Just as you're about to report your findings to the elf, one of you realized that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below. the winning card equal to the number of matches. So if card 10 were to have 5 matching numbers, you would win 1 copy of each card, 11, 12, 13, 14, and 15. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. So if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won, cards 11, 12, 13, 14, 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. Let's read through this. I don't know that I understand it first brush or first pass. This time the above example goes differently. Card 1 has 4 matching numbers, so you win, copy each of the next 4 cards. Card 2, 3, 4, 5. Your original card 2 has 2 matching numbers, so you win 1 copy each of card 3 and 4. Your copy of card 2 also wins 1 copy of each of card 3 and 4. Your 4 instances of card 3, 1 original and 3 copies, have 2 matching numbers, so you win 4 copies each of card 4 and 5. Your 8 instances of card 4, 1 original and 7 copies have 1 matching number, so you win. Well, this is a little fascinating. I'm just trying to think about how it approaches this problem. So each time we process a card, there is this possibility that more records will be injected after. So there's two thoughts here, and that is we're copying card 2, 3, 4, and 5, but we have to process the card in numerical order. So for instance, when we process card 1, we get a copy of 2, 3, 4, 5. Those are inserted into slot 2, into slot 3, into slot 4, into slot 5 as a duplication. Okay, so I could expand the input, but I think that's a waste of memory space. Really what we're saying is when we process card 1, record 1, we need some sort of indicator or counter that tells us how many card 2s we have, how many card 3s, how many card 4s, how many card 5s. We don't care about how many wins. There's 2 things we'll have to do. Number 1, we will have to pull out the card and we'll have to catalog it. The second thing is we can put in a map the number of duplications of that card that we have, and then we can reprocess that record X number of times. Okay, I think I have a plan. So here's what we're going to do. We're going to loop through these sets of lines, and we're going to maintain a map of the card IDs. And that map is going to be a map of card ID to int, and each card ID that we process, so 1, 2, 3, 4, 5, 6, etc., we're going to store in that map. So the first one will just be a 1 and a 1, which is fine. It's kind of throwaway, but we could do this for each one. Actually, we don't care about the first one. What we care about is the number of duplicates, or the number of times we need to process. We could even pre-process them, but I suppose we can get the total number of count from our map. Yeah, we'll do that. So what we're going to do is when we see that we've got 4 wins, 4, so 2, 3, 4, and 5, we know that we're on card 1. So card index 2 gets a +1, 3 +1, 4 +1, 5 a +1. And we always start at 1 because we know we're going to at least process that record once. So when we get to card 2, we check the map to see how many records are in there. If for whatever number is on that line, we process those forward. so on and so forth. So if we check the map, since there's going to be 2 in there, 1 for the initial plus 1 for this duplication from card 1, we know that we have to process it 2 times. And then we do the same thing for 2, 3, 4, 5. And then what the map is going to hold, the map will hold all of our counts. Let's walk through this and let's think about how we're going to restructure our code a little bit here. So score, we don't really care about wins and plays anymore. We only care about, we're going to do a part 2. Okay, part 2. And we have this same input, but our value is 30. Okay, so we're going to go here. Expected 30, actual 13. That's fine. So part 2, for each line, I'm not going to break this out this time because I need the IDs. Oh, the wins do matter. I take that back. We do need to do the score. So we do need this function because the win is the number of records that we're going to process, the number of duplications forward, right? So if we're on card 1 and we get back 4, which is the total count, but it's a different score. So okay, so the scoring's slightly different. It's just plus equal 1, and that's not true. Score 2. Real awesome names, right, guys? Score 2, and then I want to return the ID. So yeah, because then this becomes multiplication. So I'm actually not going to reprocess it each time. Just bear with me. Terrible naming. It's ID scorecard now. SC equals ID SC sub 1 ID equal ID SC sub 0. But that's not entirely true. What we have is card 1 at this point. So then we've got to do strings.split sub 1. This is we'll just handle that real quick, and then we're going to return the ID and the score from here. I realize like we're kind of, maybe we should handle that outside. I don't really care. So now we get the score, and it's just the raw count. It's the number of records down that we need to go. So what we can do now, score 2. So All right, so we've got our ID and our score. So here's map of int, because that's going to be our ID, and int is our count. Right? Okay. So, and there's always going to be one record 1 in here because that ID doesn't exist, right? I think there's an edge case here at the end, but let me keep iterating. So what we're going to do is when we get back a score, and this is ID 1, if our score is, say, 5, we'll say for I equal to ID, I is less than or equal to ID plus score. So that's our number of records forward. I plus plus. Okay. So what we're doing there is we're saying we're going to start at, so for the first record, okay, if we go back to our example, let's look at our test example. I'll grab an excerpt. So this map here is going to be times to process basically. And for the first pass in, card 1 only has 1 time to process. So we know that it's just going to be 1. Let me change this to J down here. Subber ID. Okay, so what this first part is saying is that we're going to process this record at least 1 time, and I has to be less than or equal to our times to process. So based on our card one, we're going to process it 1 time, and so this would go through 1 time. And what we're saying is for the number of records returned, so that'll be a 4, right? In this example for score 2, we're going to loop through, and what we're going to do is J starts at the ID of, hold on, let me just think about this for a second. If the score is 0, we don't need to do anything. So I'm just gonna, if score equals 0, we're going to continue to the next record. All right, cool. So if we have at least a 1, right, we're going to start at our ID plus 1. So it's the next record because we know that we've got at least a 1. That's our first we want to process. And then it's going to be our ID plus our score. Do I have to plus this by 1 as well? So that means that it would be 2, then 3, then 4, then 5. Right? Which would be our 4. Yeah, okay, I think this is fine. Starts at 2, then 3, then 4, then 5. I think that's right. All right, this should be a J. All right, and so what we're going to do then is we're going to write to our map. Hold on. I may not need the I iterator. No, I don't. So J plus equal whatever is in our ID. So if one more thing, if we don't find t.j, sorry, I forgot, it's the second variable, that's the OK. Technically this worked up here because I used a bool, But if you actually want to do the OK check, you have to use the second. So you have to kind of throw the first one away. So I want to do this one thing, which is if we come across an index that doesn't exist, initialize it to 1, because every card ID that is processable is at least going to get a 1. Now, I think there's an edge case. Okay. This might work. We're going to run it. Actual 0. Oh, because the actual score. So our score. So for range of t, is just tallying up all of the numerators on the cards. Expected 30, got 29. Okay. So the reason that's happening is because I only initialize the first card, and my suspicion is that, let's go back and look at our test results or our input. One of these I don't think has a win. If we go back in the first example, yeah, 5 and 6 are worth no points. So because both 5 and 6 are worth no points, we should end up with, we're missing one of them. Although I think we should have been off by 2. But what we're going to do is each time we process an ID, we're just going to make sure that ID exists. And if it doesn't, we'll set it to 1. Okay. All right, cool. So we're checking to see if that ID exists in there. If it doesn't, we add it, and then we increment. Now, there's one last rule that I don't think is covered in the test real well, but it has this line here that cards will never make a copy of cards past the end of the table. So I'm going to run this as is with part 2, but I think if they're clever, okay, just a little bit of an annoyance here. What's happening is there are, because of the formatting in the file, let me just, oops, there are multiple spaces. Let me just see if I can do a regex split, because really I don't. Yeah, so the problem I'm running into is that if you look at the input, there are different iterations of card, card, card. And I'm getting back 4. I think what I'm actually getting in some of these cases is card space 4. And I sort of avoided this in my other scenario somewhat tactfully. Probably got lucky because they were all 2-digit. But this one is a little bit more complex because it looks like there are 3-digit. Yeah, okay. I don't know why it took me so long to ponder that. We're still going to split, but what we're going to do is a... yeah, let's do this. var string matcher string re must compile So what this is going to match one or more spaces. If you look at our input text, that would be any of these. I don't need the even spacing. It's kind of annoying. I thought about doing this earlier, but I didn't. But I think you can do a space re dot replace sorry if I could spell space. I really shouldn't chain these things either like this, but being lazy. So what I'm doing essentially is I'm saying anything that has one or more spaces replaced with only a single space. And so what that'll do is any input that, like for instance, this will become this after the transformation. This will become this. These will become this, etc., etc. And we're only doing that for the card index. This just kind of gets me past kind of band-aiding around this whole like file formatting. All right, cool. Let's give it a shot. If this doesn't work, it's probably the edge case. All right, well, that edge case that I thought might have existed doesn't exist. Well, that's awesome. All right, so that's it. Day 4 is complete. Let's do a quick overview of solve 1 versus solve 2. So in part 1, we had to take all of the inputs of the cards and or scratch cards, and on the left side you had the winning numbers, on the right side is the numbers that you obtained. And the rule was on the first win you got 1 point, and then each win after that was double. So if you won once, it was 1 point. If you won twice, it was 2. If you won 3 times, it was 4 points. If you won 4 times, it was 8 points. So the way that you handle that is you count all the plays and the wins, and you simply just say, for each win that we have out of our plays where we match, take our score and double it. If it's initially 0, set it to 1. And that was that. Pretty straightforward. Part 2, pretty straightforward as well, but a slight different twist, and that was that we had to duplicate the number of processing or count a given card multiple times. The way we handled that is, instead of like, initially I thought like, hey, let's just create a list and we can process card 1, and then we know we have to reprocess card. I left out one detail. So you score it the same way. So card 1 was scored the same way, but because there were 4 wins, instead of you adding up the score and tallying it, you got additional scratch cards for winning. So card 1, because we got 4 wins, you would get the next 4 cards in sequence duplicated. So now instead of having only one card 2, you would have 2 card 2s to process. And then 2 card 3s, 2 card 4s, 2 card 5s. You then have to process both card 2s when you process card 2, and based on its wins, it could create card 3, 4, 5, etc. all the way down to the end of the file. But instead of reprocessing all those cards, which you could do, I thought it would be better just to maintain a count and say, okay, whenever I get to this card, let's just store how many times we have to process it, because the end result was not a score, but rather the total number of scratch cards. So the way I handled that was by creating this times to process map with the first card in there as a 1, and then what we would do is we would process each card, and as we got to that card, it didn't exist in the list, we would say we'd only process it once. And what we actually did was just count the number of times to process. And that way we didn't actually have to duplicate the processing of the record, because we would say, okay, well, if card 2 produced 1 win, which was card 3, well, we know that we have 2 card 2s, so add 2 to the number of card 3s that need to process, which will put it at 3 processed, so on and so forth. So pretty straightforward solve tonight. That's it for Advent of Code 2023 Day 4. Again, please like and subscribe. If you have any feedback or questions, feel free to leave comments. I plan to do some follow-up videos. But for tonight, that's it. Y'all have a good night.